All right, so I'm going to talk about this problem set over here, and I'm actually going to scroll through the answer key so I don't have to keep scrolling back and forth, but I'll still talk through the problems. You should try to do this on your own before looking at answer key or watching the videos, but the bottom line, there's 5 problems, and I'll be honest with you, if I were looking at the 5 problems, some of them look pretty tough to me, but 2 of them look reasonable to me. And what do you mean by reasonable? I want to point out what I mean by reasonable. I'm looking at 2 of the questions that I believe would be really, maybe I shouldn't say really, but should be easy for me to do. 1 and 5 look like they're moderately easy problems to do. All right, I'll go to the answer key and I'll talk through the answer key for you. The other ones look more painful to me, and I'll talk about those. But first I need a confidence builder. And I'm going to see between 2 and 5. 5 would be my first confidence builder question. So I want to scroll to 5 and then talk about it. So certainly, if I were looking at this and I really weren't thinking much about it, and they said, find a remainder, my first inclination would be to divide. And by the way, I mean long divide. So you do x plus 1, divide into x plus x cubed. And I'm not saying it's something you don't want to do. I'm just saying it looks really difficult to me to do. Right? And I don't really think they're asking me to do that, but you could give it a try. It just looks tough to me. But you might say, nah, I'm going to do it anyway. Do it. See what happens. All right? I'm going to suggest maybe something a little bit easier. So I'm going to erase this over here. And what I'm going to do is just write down, if I were looking at it, I know it's a division problem. I'll write that down for you. I'm not going to do a long division. I'll just write down what a division would look like to me. It's going to be x plus x cubed plus x9 plus x27 plus x81 plus x243, and I'm going to be dividing by x plus 1. Now what I do know, if I did do my long division, I would end up with a quotient. I just don't know what it is. And I would end up with some remainder. And it's unfinished business because I didn't divide the remainder by the divisor x plus 1. The next thing I would note about this over here is that I want to clear the fraction in the problem. So I'm going to multiply both sides by x plus 1. And what do you get? X plus x cubed plus x9 plus x27. That's a 27, by the way. Plus x81 plus x243 equals q of x times x plus 1 plus the remainder. And I'm saying the remainder is some function of x. So what I would do now is there's something I don't want, and I'll point out what I don't want in the problem. I don't want this. And my only way to get that to disappear is to select the x equals minus 1. And write this down for you. So if I say x is minus 1, whoops, let me get the right number down, right? So if I say x is minus 1, what would I end up with? Well, minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. All very simple computation. And there's 6 of them. 1, 2, 3, 4, 5, 6. All odd powers. What's nice about this, though, I don't need to know what q is, because if x is minus 1, this factor becomes 0, so I get 0, plus the remainder evaluated at minus 1. Well, what's nice about this? This is minus 6, so this is the remainder. What's the remainder? I'll write it down for you. And this is the remainder theorem, by the way, minus 6. All right? They wrote the remainder theorem down for you. Okay? Let's take a look. And the other problem I thought was easy to do, remember, was that ellipse problem. And let me just see where that is. Yep, right over here. So I'm going to kind of talk through it. And, someone says, what would you do to talk through it? One is I try to visualize what it looks like. And for me, looking at this guy over here, I'm going to kind of draw like a really hokey picture, but this is my x-axis. This is my y-axis. And, looking at the ellipse, centered at the origin, the x would be plus or minus 1. That's minus 1. This would be 1 over here. And the y coordinate would be plus or minus 1/2. And I'll put this right over here. So this is minus 1/2 along the y-axis and 1/2 along the y-axis in that direction. And what do I know about this over here? There's a point, a line, they say intersects this ellipse. Again, I don't really do a great job in graph, and I realize that. But I'll just say the one's up there. And there's a line now with slope m. And there's going to be a point of intersection where it just kind of grazes the curve. And this is a point in the ellipse, and that point in the ellipse is going to be x, y. It's on the ellipse, by the way. And this point up here is going to be, let's see, the x would be 0, and the y would be 1. How do I know that? Well, I'm looking at this equation. It's got a y-intercept of 1. So I can write the slope down, the slope of that line m. And by the way, I'm just doing one side. There's symmetry here. There's also a point over there, but it's symmetric. Right, so if I know x, y on this side, I know it on this side. What do I mean by that? Well, the x would be, let's say the x were 0.7 here, it would be minus 0.7 over here. I'm not saying it is. I'm just saying if I knew it was that, and the y doesn't change. All right? And what's our question? M squared anyway. So if I find m of this line, I can do m squared. All right? What's m going to be? I'll write this down very carefully, too. So it's going to be, let's see, I'd say 1 minus y. And then it would be 0 minus x. Well, I'm going to write that a little differently. I multiply top bottom by minus 1 because I don't like that minus x on the bottom. So I'm going to say it's y minus 1 over x. All right? And what else do I know? I know it's also the slope of the tangent line. Well, it's just grazing the curve, hitting at one point. It doesn't puncture the curve. It just grazes it. So I got to get the slope of the tangent line, and that requires implicit differentiation. So I need to implicit differentiation on this over here. Well, let me write that down, and I be careful too. 2x plus 8y dy dx equals 0. And I think I can get dy dx. And what's dy dx? It would be minus 2x over 8y, which is the same thing as minus x over 4y. All right, and this is the slope of the tangent line at any given point xy along the curve, as long as y is not equal to 0. All right, so what do I now know? Well, if it's a point in the curve, I'll write this down now. So you can get minus x over 4y. All right, I got a relationship now. And again, this relationship may or may not be important to me, but I do have a relationship. And this xy over here, again, is a point on that ellipse. So what I want to do is I want to kind of simplify that. And the way I'm going to do that, just kind of clear the fraction. And what would I get? I would get 4, let's see, I got to be real careful about this. 4y squared minus 4y equals minus x squared. Well, I'm going to just manipulate a little tiny bit. And what do I get? I get x squared plus 4y squared would actually equal 4y. And remember, this xy relationship has to be on the ellipse. So I know something now. And what do I know about this? I know what this is. And what is it equal to? It's equal to 1. So now I know 4y is equal to the number 1. This is kind of making sense to me looking at my picture, because I know the y's got to be between 0 and 1/2. And what's the y now? It's 1/4. Well, that was not their question. Their question is, what's a slope squared? I haven't even gotten there yet. I just got the y. Now the question is, can I get the x? And I think so. And let's go through that. So I'm going to use this equation here. It's going to be x squared plus, well, if I did 4 times 1/4 squared, I just get 1/4. And 4 times 1/4 is 1. I'm just using this equation over here. So x squared would equal 3/4, or x would equal plus or minus root 3 over 2. The question is, does that make sense? It does, because x would have two numbers, and those two numbers would be one's on the positive, one's on a negative, and they're symmetric. So now I can find out what m is on, at least on the right side. I could do it on the left side too, but not important. And what's that going to be? Well, it's this thing over here. So it's minus x over 4y, and that's what the m is. Let's write this down. So it's minus x. Well, it doesn't matter which one you take. It's plus or minus. I should say minus plus maybe. Taking the opposite of this number here. Root 3 over 2, divide by 4 times y. Well, y is a quarter, right? And 4 times that is just 1. And what do I got to do? I got to write down m squared now. And what's m squared going to be? I got to square this thing over here. And what's it going to give me? 3/4. Now let me see if I got the answer. I don't think they wrote the answer down. They did write the slope down, but they didn't write m squared down. I think I need to correct that. And again, it's square that number over there, and that would be 3/4. All right? So I just forgot to write that down. Hopefully I'll remember to write it down, not to confuse anyone. But the answer there is, what's the question? Then m squared is what number? It's 3/4. All right? Okay, so I'm going to say, for the most part, I think I've done the 2 easy questions. Then the big question comes is, what's another question you could do? And I'm looking around, and I'll be honest with you, I'm kind of looking at it. 1 scaring me, right? That would be a scary problem for me. 1 and 5 didn't scare me too much. I'm sorry, 2 and 5 didn't scare me. So I'm going to say 1 for the last one. But maybe it's not as difficult as I think. I'm just reading it like a rowing boat and all kinds of things like that, and water moving. A little bit confused. I think I'm going to attack 3. And I want to see if I can do it without going right to the key, right? But again, we can write in the key. I got a little space. So it says, for this equation, x is real, b and c are each real constants, and b is less than c. Find the possible values of y. Now, I want to tell you, when they're telling me this, really what they're asking me for is they're asking me for the range of this function. And I don't know it, looking at it. So what I want to do is I want to write down, what does this thing look like to me? It looks crazy to me. It looks like this, though. X squared minus bc over 2x minus b minus c. Well, right now when I do this, I realize it's a rational function, right? Provided x is not equal to b plus c over 2. And that would be an asymptote in the problem. So I kind of know what this thing looks like. And the reason for that, the degree of the top is 1 more than the degree of the bottom. So I'm going to say, there's going to be an asymptote somewhere. This will be the asymptote. And then I'm going to see something that looks, relatively like it has a slant asymptote like this. And then I got a picture that looks sort of like this over here. So really what I got to do is I got to figure out what these values are. And this over here was known as a relative min. And this over here is a relative maximum. Now, if you haven't had calculus, that might be a more difficult thing to even consider. But if you had calculus, what you're going to do is take its derivative and try to figure them out. And let me go through that with you. So I'm going to write down dy dx, and I'm hoping it's going to go really smoothly. If not, I'm going in the wrong direction. I'm going to square the bottom. Bring the bottom to the top, taking its derivative, times the derivative. I'm going to erase that because I have to be neat, because I don't want to confuse letters now. So 2x minus b minus c. The derivative of the top is going to be 2x minus the top, and I got to be very careful, I really do mean that, times the bottom, which is 2. All right, this is going to get tough if I don't simplify. And so I'm looking at it, and I want to see if I get that top in an easier, more compact form. Because if you remember in calculus, if you can't get it in a nice, factorable form, it's going to be a really tough analysis problem. But the bottom is really easy. I'm not going to do anything with that. It's a top that's creeping me out. And I want to do a little side work for you. And what am I seeing? I'm seeing 4x squared. I'm just doing this first. That's 4x squared minus 2bx minus 2cx minus, I'm going to do this now, 2x squared plus 2bc. Well, I'm starting to see something, and I don't know if it's easy, but I'll write it down for you. I'm seeing 2x squared, and then I'm seeing this over here. I'm going to write it down. It looks kind of hard to write down, though. So I'm going to put down 2b plus cx. Let me see if I got that right. Minus 2bx. Yeah, I did all right with that. And then you get plus 2bc. All right, still going to try it. Well, immediately notice a 2 comes out. 2, and then you get x squared minus b plus c x plus bc over 2x. Getting a little nervous now. Is this going to keep going, or is it just going to peter out into something really difficult? I don't know. Let's try a look. 2, I'm going to try to factor that. 2x minus b minus c. And let's see, I'm going to say bc, right? Minus minus. Does that work? You do get x squared. You get minus bc and minus cx. Yeah, it works beautifully. So what do you do now? And again, this is a derivative over here. I analyze the derivative, and they're just going to be analyzed on an interval. All right, this is a derivative now. And that interval is going to be, well, it's, the bottom. I got to look at what the bottom is 0, and that's not, also it's going to be, I have to exclude it from the domain anyway. So this will be b plus c over 2. That point needs to be removed from that line. It's not in the domain of the problem. The other 2 points I have to put down, I got to be really careful about this. I got to put down c, and I have to put down b, because those things change their signs there. But I got to remind myself what it said. And it said over here that b is less than c. So I know, at least on the line, that b would be less than c. All right, let me write this down. B is less than c. All right, they did tell me that b has to be below c. Now, I'm going to do something that might be a little tricky to you, but I'm going to put this over here, b. Let's see if I can do that simply. bc is 2c. Would that be agreed? Because I'm adding c to both sides. Then I'll divide both sides by 2. And so b plus c over 2 would be less than c. So now I know c's over here. Right, now some people are faster than others at that, and there's nothing wrong with being faster than others. All right, let me do another one. I'm going to add b to both sides. So, whoops. And again, you catch now what I'm doing over here. 2b is b plus c, and then divide both sides by 2. And you would get b is less than b plus c over 2. So I know b's over here. Now someone says, why do you go to all that trouble? The reason to go to that trouble is so I can analyze the function now. And what function are we analyzing? Well, we're actually at the original function, but I'm doing it through the derivative. And I just want to make sure you understand that I have a pretty good idea what it looks like at this point. And what do I know about, just looking at it? increasing over here, decreasing there. Whoops, sorry about that. Decreasing over here, decreasing there, increasing over there. All right? But let me think through it. Maybe I made a mistake. So if you're above C, I hope you realize that the bottom is always positive. And if I'm above C, all the factors are positive. I'll put this over here, as expected. Now, let's go, I'm sorry, this is B over here. Let's go below the B, like, you know, I don't know, if you took like B minus 1 and plugged it in. And if you, again, I'm saying it's below B, right? Let me make sure you know what I mean by that. B minus 1 is below B. If you're plugging in, the bottom's definitely positive. And now we're definitely below C, so it's definitely negative, right? Negative, negative. Yeah, positive. Simple sign analysis, right? Let me get my eraser out. Now, of course, going in between these guys over here, a little more difficult, but I think you're getting a feel for it, right? I think you're getting a feel for it. So a little bit below, yeah, a little tiny bit below C, and a little bit above B. I hope you realize what I'm talking about over here somewhere, all right? That everything would be what? Let me see. If I'm going a little bit below, the bottom would be positive. Let's see, the 2 for, oh, negative. Put this over here. Simple sign analysis. More abstract though than having real numbers, right? And then if you do the, you know, over here, a little bit above the B, like, you know, slightly above the B, you know, this term over here would be positive. This one would be negative. So negative. So now what do I know? And you may forget why you know this. I know that the maximum occurs here and the minimum. And these are relative, by the way. So the relative minimum is going to occur at C, and the relative maximum is going to occur at B. And yes, this is a more difficult problem. What I have to do is plug it in to find out what those numbers are, because the range are the Y numbers, not the X numbers. So what I'm going to do is plug in the B. And someone says, where do you plug it in? Into the function. Sorry about that. Into the function. So what I'm going to do is I'm going to plug C in first. And what do you get? I'm going to do this first. You would get C squared minus BC over, I'm plugging a C in, 2C minus B minus C. This looks crazy. Let's see if we can factor that. C, and then you would get C minus B. On bottom, what do you get? C minus B. Well, C does not equal B. So these things cancel off. Did I do that right? And you get C. Wow, wasn't expecting that. All right, let's do the B now. Let me erase her out. Erase this business over here. I'm done with that. And now I'm going to do this B guy. And I wonder what you get there. Well, let's see. You get B squared minus BC over 2B minus B minus C. Well, on top, what do you get? B comes out, and you're left off with B minus C. And on bottom, what do you get? You would get B minus C. So these things cancel off. You get B again. Miracle. So what do you get over here? What's the range going to be? Well, the range is going to be minus infinity up to B. It touches it, and then it misses a bunch of points between B and C. And then it picks up again at C and goes off to infinity. All right, let me repeat this. Mistakes can happen. All right, happens all the time. So let's take a look. And let's see if we got the right answer over here. Yeah, right over here. All right, and they did very similar analysis. A lot neater when you type it up, by the way. But it's really not a bad question. All right, a little bit scared at first, but then things kept falling into place over here. So let me just make sure that I'm tackling problems that I said I could tackle. And let me start to erase things now. And that one's still scaring me. And we'll talk about it. I'm going to try 4 now. And I guess like any teacher, they erase the whiteboard, their blackboard, and they want to, start with fresh paper. And you should too, but I've got an exam, don't erase your work, all right? Even if it looks crappy. Even if you're ashamed of it, don't erase it. Could be useful. Maybe something there they could use. I see some students spend more time erasing than they do writing. erasers, it usually takes a lot longer to erase your work than to do your work. Anyway, I get everything. But yeah, I want to talk through the problem now. And I'm going to use the answer key to do it. And we're probably going to talk to, we did 5, that was easy. I don't think I did this one, right? So what I want to talk about is how to do this problem. And the first thing I would do is says, there are 2 common roots in the following 2 equations. So I'm going to claim the roots of this one here, these are the roots. I'm going to claim the roots are A, B, and C. It's a cubic polynomial, by the way. Let me put some set notation on that, not like an ordered pair of numbers. So it's a set. These are the roots. And the roots of this guy over here, well, what did they say? They said they share 2 common roots. So I'm going to say the roots of this thing, the common roots, I'll just simply say the first 2. And then there'd be something that's not common, D. So what I'd like to do is, notice that the coefficient of the leading term is 4. So what I want to do is, I'm going to take the first equation and divide through by 4. And I'm also going to do a second equation. And if you do that, what do you get? You would get, well, let me write this over here. By the way, there's better pictures provided for a reason. If you remember my ellipse picture was pretty bad, this is a much better picture over here, more accurately drawn. But let me write this down over here. So it's going to be x cubed, I'm dividing by 4 in the first equation, plus 3x squared plus 11, I'm dividing by 4, by the way, quarters x plus m over 4 is still equal to 0, by the way. All right? And if I did the second equation, divide by 4, you'd get x cubed minus 5x squared minus 21 quarters x plus n over 4 is still equal to 0. And they still have the same roots. So what do I mean by that? The first equation, the roots are going to be, let's see, x minus a. This is the whole reason for me dividing by 4, by the way, because now the leading coefficient's 1. X minus b and x minus c. And the second equation, it's going to be x minus a, x minus b, and then the root that differs would be x minus d. They're both cubic polynomials, by the way. So what I want to do is I want to look at the work, and I want to point out that's written down for you, all right? So I'm going to say, kind of, whoops, and I keep doing it, I know that. So I kind of know why they did that, right? And what else did they do? They did it for the other one, too, all right? So I want to point out that's written down for you. I see the x cubed, 3x squared, 11 quarters x, m over 4, and then I see the x cubed minus 5x squared, 21 quarters, n over 4. Right, the next thing I would do, oh, by the way, these are equal to 0. I would expand it. All right, now someone says, why would you expand it? The reason for expanding is so I can equate coefficients later on. So I'm not going to go through the expansion, right? I think you could probably do it on your own, or if you knew something about how to multiply without doing it on your own, you could probably get it. But it's going to expand out to look like this over here. And this one would expand to look like this one over here. All right, now someone says, why would you do that? So I could equate coefficients. All right, so what I mean by that, looking at it, clearly, those things have the same coefficient. Clearly, these have the same coefficient. But what I'm going to write down now is the other guys. So I'm going to say the x squareds have to have the same coefficients. So the number 3 has to be the same thing as minus a, minus b, minus c. All right, and over here, I'm going to say minus 5. Again, the square terms, x squared terms have to have the same coefficients, equals minus a, minus b, minus d. I'm going to simplify a little bit. I'm going to say minus 3 equals a plus b plus c. And over here, I'm going to say 5 equals A plus B plus D. I'm looking at these two equations, though, and I think to myself, maybe I shouldn't have done that. Maybe I should have just looked at this one here and this one here and added them together. Let me do that for you. I'm going to take this and see what we end up with. Well, I'm looking at it, and you would get 2 if I added those two equations together. I hope you can agree with that. It might go nowhere, but I'm just looking at it. It looks like it might be easy to do. You know, I'm not going to do those two. Let me go backwards. Let me go backwards more. I am going to do these two. And if I did that, I would get 8 equals, let's see, the A disappears, the B disappears, and I'm left off with D minus C. By the way, I'm not saying that's going anywhere, but at least there's some simple relationship now with D and C. All right? So let me keep going. And let me equate some more coefficients over here. Let me get a different color. I'm going to go to, I don't know, I'll go to yellow. So I'm going to say maybe yellow doesn't look good. I'll go back to black. AB plus AC plus BC is equal to the coefficient on the x term, which is 11/4. And the AD plus AB. I'm sorry, you know what? I'll go in order. I'm looking at this now. B plus AD plus BD is equal to minus 21/4. All right, let's take a look. I'm going to do another subtraction, and I'll see what I come up with. 11/4 minus 21/4, or minus 21/4 is 32/4. Again, I'm taking this equation, and I'm subtracting this one. And again, it might be a dead end. All right? So 11/4 minus 21 is 32/4, so that's 8. I'll write that down for you. And then the AB would disappear. You would get AC plus BC minus AD minus BD. You know, I'm going to factor that guy. So 8, let me just put a little thing here. I don't want to confuse that 0 there. Let me be careful about this. Did I copy that right? AB, that disappears. We get AC plus BC. And then you get minus AD minus BD. I did the subtraction, and let's see what you end up with. Let's take a look. C comes out, right? And what are you left off with? A plus B minus D A plus B. Wow, that's nice. So you get 8 equals A plus B times C minus D. Okay, I'm seeing something now. I'm seeing C minus D, and up here I see D minus C. So I know this now. From looking at this, I know this. 8 equals A plus B, and C minus D is actually just minus 8. So minus 1 equals A plus B. So I'm getting I think some simple relationships, but nothing concrete at this point. And I want to go that my next guy, right? So it's over with the next guy, just equating coefficients over here. And I'll kind of write this down for you. And I know that minus A, B, C is M over 4. And I know minus A, B, D is equal to N over 4. All right? I'm kind of running out of room. Let me go to the next page and see what we got, see if we got those relationships down. And I want to point out, I want to make sure I got this relationship, and that relationship is 8 equals D minus C. Yep, we got that one. I want to see if I got the other relationship they're saying, which is A plus B equals minus 1. Yep, I got this one over here. All right, so let's move forward. All right, we got that. So I got an additional relationship over here, but I don't think it's very useful at this point. So let's keep going. And again, I want to point out we're getting these things over here. And then the next question is, how are you going to do this over here? And I'm going to use this information for some simplifications. And let me write down what I mean by that. I guess I could write down this is equal to this again. And I guess I could write down this is equal to this again. Let's write that down. Minus A minus B minus C equals 3. Now, do I have an A and a... I do, it's right here. But I need to get A plus B then. So I'm going to multiply by minus 1. It's going to be A plus B minus C. I'm sorry, plus C, sorry about that, equals minus 3. I multiply by minus 1. And A plus B is minus 1. And lo and behold, I found C. What's C going to be equal to? C is going to be equal to minus 2. All right? That's right over here. All right. I think I can find D now. And how do I do that? Right over here. So, this is a long problem. I know that. I know it's a long problem. So what do I got? I have 8 equals D. I don't know what D is, by the way. But I do know C is minus 2, so it's going to be plus 2. So D would have to be 6. All right, let's go back over here, and I see this. So now I know C, and I know D. All right, so someone says, what are you going to do now? I could equate the other coefficients, but I'm starting to realize I have some roots to the problem. And let me go back over that with you. If you think back to the beginning of it, what was I saying? I know some roots. And again, I want to remind you, we have one of the roots is minus 2, right? So C is minus 2. And we found the D to be 6, right? So what I would do is plug it in somewhere. And what I mean by plugging it in, like here. And let's plug it in. Let's plug in the C. And I'll do that right now. So you would get minus 8 plus, well, that would be 48, right? Minus 22 plus M equals 0. I think I can find M. And let me do that for you. So let's see. I can be careful here too, right? So it looks like M, well, minus 8 plus 48 is 40, and 40 minus 22 is 18. So M is minus 18. Let me go to the K. Whoops, sorry about that. Oh, I think I did something wrong there. Or did I do something wrong? Did I plug in the wrong spot? M is minus 18. Did I put that down? Well, I think I got them backwards. Maybe I wrote them down differently. Did I just do that? 4, 12. How could I have made that mistake? Maybe I chose different things. I gotta be careful here, don't I? Maybe I made a mistake in my key. Let me try that again. C is minus 2. Did I say that? Yep, it's over here. And then I'm plugging it in. And how did I do that? Minus 8, 32. I see it now. I made a mistake. And I want to correct it. This is wrong. Sorry about that. I wasn't thinking. Let's do it again. Boy, it'd be nice to have an edge key in an exam, right? So I'm saying C is minus 2. And I'm saying C is a root of the first equation. So, minus 2 would be minus 8, so it's minus 32. I made a mistake before. I didn't multiply by 4. And this would be plus, 4 times 12 is 48. And then minus 22 plus M equals 0. Let me keep going. Let's see, minus 32 and 48, that's 8 and 8, 16. And that's going to be minus 6 plus M equals 0, so M is 6. Sorry about that. Let's go back over here, and we got M is 6 now, all right? Now let me do the N, and I'll do the N over here. I want to get the N now. And I know that D is 6. Oh, it's going to be more difficult for me. And I'll write it down for you. So 4 times 6 cubed minus 20 times 6 squared minus 21 times 6 plus N equals 0. I am going to factor out a 6 because it's going to make it easier for me. And again, your mileage may vary. This would be 4 times 36 minus 120 minus 21 plus N equals 0. Boy, it's a lot of work, isn't it? 4 times 36 is 144 minus 141 plus N equals 0. 6 times 144 minus 141 is going to be 3 plus N equals 0. So N is minus 18. Let's hope I didn't make any mistakes. Yeah, got it right over here. Now, I realize there's something to say, I don't know what to do next. Read the question. Let's read it. What did they say? Determine the values of M and N and all roots of the equation. We've already done that, but I have not done all roots. I've done some of the roots, but not all of the roots. Now, I got to get C and D. All right, I got to cut to the chase. I'm probably not going to do the work because I realize I have to do that river problem still. But once you get the M and N, you plug it in, and then you do, I would say the best thing to do is probably do the divisions to do the problem here, okay? Now, what I mean by that is, you're looking at this thing over here, and let me make sure I did this thing right. So I said the M was 6, and I plugged that in, and I plugged the other equation in. And let me make sure I'm doing this right. It looks like what I did is, I'm just going to, because I really have to get that other problem. It's taken a lot longer than I thought. I'm subtracting them. So yeah, I'm agreeing with this over here. And what do you get there? And you get 32x squared, 32x, and 24. Looking good. And then what I would do is I would divide by 8. And I would get this. And then I'd use quadratic formula to get this over here. All right, it's complex root, complex conjugate. And they're the roots, all right? They're the roots they share. All right, and I think that's about it. Yeah, okay, so that was a tough, long problem. No doubt about it. That was probably the worst problem I have seen in these problem sets so far. All right? But I want to get back to that river problem. And again, the way people do these problems, it really, and sometimes I'm surprised how people do problems, including people who are really bad at algebra. They read problems and say, oh, it's obvious, the answer is this. And I always find that to be, I'm not a very good non-algebraic reasoner. So I'm going to say a man rowing upstream drops his hat at point M. He's going upstream, he's at a point M, and he drops his hat. Now, by the way, when he drops the hat, drops it in the water, and the hat's going to start to flow downstream now. But he continues to go upstream. All right, so the man rowing upstream drops the hat at point M. 30 minutes later, at a point N. So this is 30 minutes now. All right, he's at a point N. He notices it's loss, and he's got to row back. He's got to row back. All right? So what I'm going to do is talk about, the rowing in still water and the rowing in moving water. And although this is not 100% true, it's roughly true. Like when you're rowing against water, it's working against you. And I'm going to say it's a linear relationship. So I'm going to put this down. I'm going to say, the rate of the boat in still water. I'm going to outline this for you. So I'm going to assign letters for this. So, I'm going to use algebra. It's recommended you assign variables. I'm going to say R. Whoops, I didn't mean to do that. I'm going to say R is the rate of the river. And B is the rate of the boat in still water. I'm using a uniform motion problem. What do you mean by that? Distance equals rate times time. And I'm going to say rates are additive and subtractive. Like when you're rowing with the river helps. You add the rate of the river to your boat speed. And if you're rowing against the river, it hurts. You take it against the rate of your boat speed. So I'm going to say, I want to kind of understand what they're talking about over here. And I do know they mentioned that he picks his hat up 440 meters. I'm sorry, yards, not meters. Sorry about that. So yards downstream. He gets it downstream from M. Find the rate of the stream and the total elapsed time. All right, so I'm definitely going to use uniform motion. All the rates are going to be in yards per hour. All right, let's talk about it. So I'm going to tell you that the distance, let's put this down, this guy's distance over here, right? That this thing, in the total time, right? Let me write this down. The total time. So distance equals rate times time. You know what? I really probably shouldn't use that R there. So I'm going to write down in words. Let me get rid of this thing over here. So distance, this is uniform motion, equals the rate times the time. And let's talk about this 440 meter thing here. And the only thing working on the hat, by the way, was the rate of the river. And I called the rate of the river R. So it's going to be rate times the total time, where T equals the total time. This is total time. So I'm going to say 440 over R is the total time. So I want to point out over here is this is the time, the total time. Now, the question is, how much time did this guy spend getting back to his hat? Well, what he did was he went upstream for 30 minutes. Was that agreed? And how many hours is that? That's a half hour upstream. He spent the half hour doing it. But then he had to go back downstream. And back downstream, he had to do two distances. He had to do the 440 Whoops, sorry about that. You had to do the 440, and you had to do this distance over here. So someone says, I wonder what that distance is. Well, let me write it down for you. So the distance here, right, this distance here, I'm going to put down the distance here. Let's call this D1 or something. That distance would be what? Well, it's going to be rate. What's this rate going upstream? Well, the rate of the boat, the rate of the boat's B, minus the rate of the river times a half hour. That's what that distance is. All right, let's go over here. And I want to point out that's going to be a distance. And he has to go that distance. But he also has to go this distance, too, to get back to the hat, which means he's got to go an additional 440. So I want to point out what this is over here. This is the amount of distance that he needs to cover on the way downstream. And a lot of work, there's no doubt about it. Then the question comes is, what are you doing now? Well, I know that distance equals the rate times the time. So really what I'm trying to do is get the time. So I need to divide by the rate of going downstream. And what's the rate of going downstream? Well, it's going to be the rate of the river plus the rate of the boat. And that's why this is over here. So again, what am I doing? I'm doing distance. That doesn't look right, does it? I'm really sloppy with penmanship, I know that. It's distance over rate would be time. And that's where that's coming from. All right, so I got an equation now, and it looks terrible. There's no doubt about it. What I'm going to do is start simplifying it, one step at a time. So I want to point out I'm doing, it looks like I multiplied both sides by 2. Well, I see the 880 over r. That's good. 2 times a half is 1. It's good. And 2 times the other side, that second term would be 880 plus b minus r. Looking good. All right? The next thing I would probably do is get a common denominator. And what's this going to be? I'll write this down for you. It would be r plus b, and then you get r plus b plus 880 plus b minus r. And what is that going to give you? 880, you get 2 b's and no r's. I see that over here. And then, kind of looking at it, let me see what else I could do. I guess I could divide through by 2. And that's how I got this one over here. I divide everything by 2. So it'll be 440 over r, b plus 440. Then I clear the fraction. You get 440r, 440b, and then what do you get? You get br plus 440r. I'm seeing everything now. Right? I don't know where I'm going, but I'm seeing everything. And yeah, I notice this problem set's taking a lot longer than normal. All right, I'm at this stage over here, and then what I do is I probably get stuck at this point, but I don't want to get stuck. I want to kind of look at it. I'm seeing that 440r, I can subtract it from both sides, and I'm left with 440b equals br. Right? Then I'm going to do this over here. 440b minus br equals 0. Then I'd use the zero product rule, and what do I get? I get b times 440 minus r. By the way, b can't be 0. B's got to be some positive number. But what I do now know, I know now the rate of the river. What's the rate of the river? Because the only way for this product to equal 0 is if the rate of the river is 440. And what's it going to be? Yards per, what unit did I use? I think I said per hour, right? Because I did the analysis. Yeah, per hour, I'm sorry. So that's the rate of the river. Now, someone says, how you can get the rate of the boat? First of all, let's see if they want to know that. Let me see what they want to know. So it says, man's rowing 30 minutes later, point, picks up his hat, find the rate of the stream. Oh, I got that. I got the rate of the stream. It's right over here. And the total time. And the elapsed time. I think I can do it. And it's right over here. And what's that going to be? 1 hour. Because if I took this 440, which is the total time, and divide it by rate, which is 440, what do you get? You get 1. Total time is 1 hour. All right? So I'm going to say not that bad. All right? Really not that bad. Total time's 1 hour. And, certainly I put a lot more down here, but I do want to point out that some people's skills at reasoning are quite good. All right? So thinking without algebra has always been my weak point. However, let's give it a try. Since the man rows away from the hat for 30 minutes, he must row back for the same time. Thus, the whole trip took 1 hour. The stream has moved 440 yards in 1 hour, so the rate of the river is 440 yards. Some people see that as being obvious in the problem. I don't see it as being obvious. But after doing the algebra, it might become obvious to you. All right, I realize problem set was tough. I want to point out what I mean by that. For me, the most difficult problem is number 1. The easiest problem was 5. I'd say 2 comes next in my line. 3 wasn't bad if I knew calculus. 4 was a lot of work. And 1 to me was an entire, I had to really kind of think through that problem. It took me time to get through it too. All right? If you need to reach out to me though, my email address is Bannon, that's B as in boy, the @ symbol, NNON.US. I know this was a long, tedious video. Here's the deal. If you do need to reach out to me to tell me, oh, I did something wrong or I said something wrong, you can do that. Try not to be too pedantic though. But if you have something to share that you think would help other people, please do. All right? The whole point about this is to share. We're trying to encourage people to share information. Here's the deal, though. These videos are not popular. If they become popular and I'm getting thousands of emails, I just can't deal with it. All right? That's a possibility. I don't think that's going to happen. But if it does and you don't get an answer from me, you know what? It's because too many people are emailing me. And I do apologize in advance if that does occur. But again, thanks for paying attention. I really do appreciate you being here.